Hi, happy morning to all. Today we will discuss about this AS level question in reaction kinetics. Oxidation of ethane dioate. Ethane dioate is nothing but oxalate anion. This is actually ethane dioate. I will mark this ethane dioate. Ethane dioate. We can represent this ethane dioate like this. This is for just information. This is actually oxalate anion. Oxalate anion, the other name of oxalate anion, that is the IUPAC for oxalate anion is ethane dioate because it is a derivative of ethane dioic acid. You know about the carboxylic acid. Carboxylic acid has the name oic acid. Here there are two carbon atoms. That's why we are saying this as ethane dioic acid, and they are asking oxidation of ethane dioate ions by acidified manganese 7 ions. Why they are calling this manganese 7 ions? Manganese 7 indicates the oxidation state of manganese in MnO4 minus. Let us check whether the oxidation state of manganese in MnO4 minus is plus 7. For example, I will take that oxidation state of MnSAX. We know the oxidation state of oxygen in oxide will be minus 2. So 4 into minus 2, that will be minus 8. There are 4 oxygen atoms, that's why this is minus 8. The overall charge on this part will be minus 1. So X is equal to plus 7. So the oxidation state of manganese will be plus 7 actually. So plus 7 has been indicated here. So while during that reaction, while the reaction is happening, we will add the C2O4 2 minus ion to MnO4, right? So MnO4 minus ions. Here the question is Mn2 plus act as a catalyst. If Mn2 plus act as a catalyst, which graph shows the concentration of acidified manganese, that is manganate 7 ions variation? How the variation will be? The question is like that. Look at this here. The product is an oxidation state. Sorry, product is an autocatalyst, is acting as an autocatalyst. So Mn2 plus acting as an autocatalyst. So initially the catalyst will not be there because the product is not at all formed. So initially the reaction rate will be slow. Look at this. This graph shows like that. Initially the reaction is somewhat slow. The concentration of MnO4 gets reduced because it's a reactant. So reactant will be always high when the time is 0. So when the time is 0, the reaction rate will be always, the reactant concentration will be always high. So MnO4 concentration will be very high at initial rate. And then after proceeding, that is after taking 2 or more seconds, what will happen? There is a small decrease in the reactant concentration. So what is rate actually? Rate mean, the meaning of rate will be, that is the experimental rate will be change in concentration of the reactant with respect to time. So initially the rate is normal. It's not so high variation because autocatalyst is not at all formed. After some time, autocatalyst, that is product concentration getting increased. So Mn2 plus is here. So Mn2 plus shows the reduce in concentration in a different rate. So Mn2 plus acting as a catalyst, and it shows a reduction in concentration in a fast rate because it acts as an autocatalyst. So this graph is the only suitable graph for the reaction because the autocatalyst formed after some time. So this is the time to get the autocatalyst, and then that is autocatalyst is formed during the reaction process. When the autocatalyst concentration is high, what will happen? It acts as a catalyst and it will proceed the reaction in a fast manner. So the rate of the reaction will be increased. So the concentration of MnO4 will be suddenly decreased at this region because of the autocatalyst. So this graph will be the suitable graph. We will see other question in one more video. Thank you.